Hi students, welcome back. Now we are going to have the hardware demo of our burglar alarm system. We are going to see how does each component look like and how do we operate them like PIR sensor, potentiometer, push buttons and all, and then how do we connect the complete circuit in a step-by-step manner in this video. Hi students. So before we start making the circuit for our burglar alarm, we should know each component. So the first one that we have here is a PIR sensor. On the top we have the Fresnel lens. On the back side we have the connecting wires, and here is a potentiometer to set the sensitivity. We are using an external potentiometer to set the sensitivity in our project. And these PCBs and all, they will take care of all the computations and providing output through the pins. So there are 3 pins. As you can see, there are male kind of connections coming out from this sensor. That means it is going to connect with one female jumper. So this is a module which comes with this kind of attachment. One is for ground, one for VCC and one for signal. You should read the data sheet very carefully if the numbers or the values are not written here, that which pin corresponds to which kind of signal, and that will get attached. So you should be careful, it will be attached only in one direction. There is a groove here and there is a groove here, so this will fit like this with a click, and this is how you connect. And now these 3 wires can be taken to the breadboard. You should be very carefully looking at the colors and connect them appropriately. So the next one that we have is a potentiometer. This is a potentiometer which comes in a PCB module type. Here are again 3 pins, 3 female connectors will be connected, and then these will go to the breadboard or any other component. This is fairly large potentiometer. Potentiometers are available in smaller sizes also, and you can see you can rotate this to go from one end to other end, and these are soldered here, and these 3 wires can go to 3 pins. Potentiometers are available in very small sizes as well. With the help of a screwdriver you can rotate it, and on the back side you can see there are 3 pins to connect to 3 different terminals. The next component that we have is a push button. This is in the PCB format. Here, this is the push button and you can push it. The 3 wires are connected to ground, VCC and your signal. When you push this button, the button is connected to the VCC, and this cap is provided so that you can push it very easily. Well, push buttons are also available in different shapes and sizes. Here is another version which is very smaller, and on the back side you have 6 pins. That means all these will be connected. It can provide the option to connect 3 different circuits, and this one, when you push it down, it will remain down, and when you push it again, it will go up. So this can remain in stable state for more than the pushing moment. Here is one more push button. So this one, you press it and it will be connected. You release it, it will be disconnected. So this is also a simple operational push button. You have to solder the wires and then take it further. Here I have SPDT switch. So there are 3 terminals. Central one is your output. One side you can connect to ground, one side you can connect to VCC. So if you keep it this way, then your connections are from these 2 points, and if you switch it this side, your connections are between these 2. So this is another kind of button that we use. So anyone you can choose based on the application and which is most suitable for your project. Then we have one more component called buzzer. So here is buzzer. It can come without PCB also. So buzzer has 2 terminals. One will be your ground and one should be VCC. So here are 3 terminals. So what are the purpose? If you want your buzzer to work on active high, that means your signal should be high and the other pin should be ground. If you want your buzzer to work on active low, that means the signal should be 0 and this pin should be at VCC. So accordingly you select two pins and this one is selected for active high, that means this is ground, and if this pin, which is my signal pin S, is for signal, if signal is high the buzzer will be buzzing, if the signal is low the buzzer will not work. So now let us make our complete circuit. We have the breadboard, the Arduino board and the power supply. We will start connecting the components one by one. So first of all, let us take the PIR sensor. So here I have, this one is going to ground. So before I connect it to ground, let me connect the ground and VCC from my board to the breadboard. So pin number 3 is ground and the next one is 5 volt, so that is given here. So now this is ground, this is VCC, and as you know that the pin from PIR sensor is going to analog pin number, sorry, digital pin number 10. So this is number 10. So PIR sensor is connected. Next, let us take the potentiometer. So I have the potentiometer with me now, and here again I am going to connect the ground. So this white color is ground. Then the next one is VCC and the signal is going to analog pin A0. Okay, next I am going to connect the push button. So here again I have ground and VCC, both are connected, and the output is going to pin number 3. 0, 1, 2, 3. Then we have the buzzer, where we are going to connect one pin to the ground and the second pin will go to the pin number 2, which is our output for the buzzer. So now we have potentiometer, PIR sensor, push button for resetting and the buzzer for giving us the sound alarm. Let us power the board now. It is already programmed with the burglar alarm circuit. So here you can see the minute movement was detected. I am going to make the movements again and I reset it again. Let us make the movement one more time and we will count whether it is going. Yes, so I programmed it for a larger section of 20 seconds and it was working fine. So now this is detecting very minute movement. If you want to bring the movements down, you can set the sensitivity with this potentiometer. As you rotate it, the threshold will increase and you can decide whether you want to detect minor movements or major movements. Now you can see I am shaking my hand for a longer duration and then it got triggered. So I have to shake it more number of time, I have to give more movements, then it is going to be triggered. So the circuit may look jumbled or unorganized at the moment. That is all fine because that is how the prototypes are designed. You are focusing on the functionality at the first attempt. Beautification, arranging the wires, giving exact color codes and with minimum crossovers, that is our second priority. So first of all, you should focus whether the circuit is working fine or not. If that is good, after that you can also learn just the way we learned in Tinkercad how to have very neat connections. You can do it on your hardware also, or if you go for PCB manufacturing, then you don't have to take that headache. So, I am sure you have learned that working with hardware is a completely different ball game compared to the theoretical concepts. There are things that may work well on theory or simulation, but you have to be extra careful when you start working with hardware and you connect the components. We will keep learning more things in our series, and in the next video we are going to talk about a password protected door lock with the help of a keyboard. Keep learning. Thank you.